Hello, professors. This is our project, Put a Ring on It, and it is a wireless doorbell that we have created. I'm Landon Ross.
I'm Kevin.
I'm Rashab Arvin. So essentially, our objective is, just for example, when in your room you're studying there is no way to know when someone is knocking at your door. So essentially, the goal of this project was to develop a simple wireless doorbell using a 433 MHz RF transmitter and receiver. After we press the switch to activate the transmitter, the receiver will then activate the speaker. And this system will be powered by two 3.7 voltage batteries so that it would reduce the spatial constraints and allow for flexible placement in the system. We will then test whether our device can pick up the signal to ring when the switch is pressed, while the speaker and LED box is in a different room. So for our description, our problem statement was when in your room studying, there's no way to know when someone is knocking at your door.
And the solution to that problem is a wireless doorbell. We simply attach the button outside of the dorm room, and have a transmitter on the side of the door, and leave the receiver and alarm side in your room. So, the project consists of two circuits. One is the transmitter side, and the other is the receiver side. The doorbell side is made up of a 433 megahertz transmitter, a 3.7 battery, and a push button switch. The alarm side is made up of a 433 megahertz receiver, a 3.7 volt battery, and a 85 decibel buzzer and an LED. So the way our project works, after you press the button, the circuit is complete and activates the data pin, and the data pin sends signal is sent from the transmitter, and the receiver picks up the signal that's delivered from the transmitter, and power is flown through the buzzer and LED, which lights up the LED and allows the buzzer to activate noise, and that is how the consumer is able to hear noise from the doorbell or know when guests are at the door.
Okay, so for our part switch, for our parts list, we started off with supporting parts such as breadboard and wires, and a 433 MAC transmitter and receiver. And then we had 3.7V rechargeable lithium ion batteries, a battery holder, an LED, a push button switch, and an 85 dB buzzer.
So, a lot of testing went into this project. If it was from testing the buzzers, which you can see in this photo here, or testing the receiver and the transmitter modules, making sure that they would all work and everything would work together. Because without testing each part individually, you wouldn't know if there's a problem with the whole circuit as a whole or just a part along the way. This is seen a lot in LEDs. So if there's too much power getting sent to the LED, it will burn out. Or if something is not connected correctly in the system, or if there's an issue, like say one of these wires isn't connected right, there could be an issue there. But you wouldn't really know unless you test everything individually. This goes to show on the right hand, you can see a 6-volt battery was made out of 4 AA batteries because it was thought that the receiver side wasn't getting enough voltage to make the buzzer go off. But it turns out there was an issue with the LED, which was burnt out, which made it not be able to flow power through and get to the buzzer. So for the operation of our project, like I said before, it's important to test every component to make sure it's a problem with the part and not with the circuit or project as a whole. We also had to learn how to use the receiver and transmitter modules. Had to make sure to add a antenna to the transmitter to make sure that it could be picked up by the receiver. And going off of these receiver and transmitters, you can see the pins in the middle are the data pins, and these are what gets activated when power flows through the VCC side right here. This is where you put the positive end of the battery and flows through to the ground side and connects and completes the circuit in here, which will then show power to the data side. To make sure to use correct wire placement, to make sure that the push button was on the data side of the transmitter so that it would know when a signal was being sent to the receiver. And there was just a lot of troubleshooting that came with the project. That was having to get a breadboard because you couldn't solder in class, or testing each individual LEDs because a lot of them would burn out, or just making sure that there was enough voltage to flow through the system. So the result was we were able to successfully address the problem statement. We were able to get the transmitter to send a wireless signal to the receiver. And yep, we had to use a breadboard, so they weren't able to be in specific rooms, in different rooms, but they were still able to send a wireless signal to the alarm. So once we get to the Mark II version of the prototype, we will be able to move them around, and there will be a working doorbell. So once we do that, then like in the video, you can see how there was there's two boxes, but there's a breadboard in between them. There's no wires running to each of them, but they are wireless. And the results just go to show that we should use an Arduino, because there's a lot more that goes into actually wiring them as circuits than it would be to just throw some rudimentary code into an Arduino and plug it in. That all comes to fruition in our conclusion. So as we said earlier, we were able to address the problem statement by sending the wireless signal from the doorbell to the alarm system. And we have deepened our knowledge on circuitry and learned a lot of problem solving when it comes to electronic circuits, because through all of this, we were able to get a prototype out there. So the next step would be to print a housing out of filament that we could put our circuits in with our batteries and our transmitters and stuff, so that we could attach that, and it would look better than just a cardboard box. So we can place that outside the door, and then we can have one or multiple into other rooms of the dorm. Yep, as you can see, the biggest issue came from the lack of the Arduino. It would be a lot easier because we would just have to plug a battery into it, and all of the supporting parts, such as the buzzer and the button and the LED and stuff like that. If we had an Arduino, we could just plug those in through wires on a board, and it would be ready to go. But instead, we did it the hard way. Another challenge that came about was having to use a breadboard. Using the breadboard made it so that we couldn't fully put the two modules in other rooms. We had to put it separate, but we were still able to send that wireless signal. And then another issue came with learning about batteries. It was thought that the buzzer wasn't getting enough voltage across to it, so a 6-volt battery was made by wiring 4 AA batteries in series to each other and then using that. But it turns out that was too much, and it burnt out the LED. So this is where the video will go of the portion of our presentation. It's a separate video of our working prototype, but it will be here. It'll also be added on to this video. And these are the two sources that were used on how to correctly use the wireless transmitter and receiver. Thank you for listening.
Thank you for listening.
Goodbye. Thank you.
Prototype testing now. As you can see, I have the doorbell on the left, the alarm on the right. So completely wireless. I have to put the boxes close to each other because I only have a breadboard. We could not solder in class. I don't have a soldering iron. So here's the prototype testing. As you can see, it sounds and lights up.